Good morning, grade 10. I hope that all will enjoy, inshallah, with our chemistry session. Okay. Now, inshallah, we are going to complete the session that we studied. Okay. This session, we are going to complete it as types reaction in aqueous solution. Types of reaction in aqueous solution. Okay. We said before that ions that don't participate in a reaction are called spectator, okay? Spectator ions. So ions that don't participate in a reaction are called spectator ions and are not usually written in ionic equation, okay? Yes, Saud. What do you need, Saud?
Sorry, mister, by mistake.
Okay, so take care, please, okay? Because I will stop my explaining lesson, okay? To understand, and discuss with you, okay?
Okay, sorry, mister.
Okay, so types of reaction, as I said, ions that don't participate in a reaction are called spectator ions and are not usually written in ionic equation. Are not usually written in ionic equation. Okay, formula that include only the particles that participate in a reaction are called the net ionic equation. Net ionic equation. So we have spectator ions, okay, and not usually written in ionic equation. Not usually written in ionic equation. And net ionic equation, okay, is a formula that includes only the particles that participate in reaction, as 2OH negative plus CuO positive 2 aqueous solution to produce CuOH by 2. It's a solid. That's called copper hydroxide. الله أكبر، الله أعظم عظمة الكبرياء، الله رب العالمين. الله أكبر، الله أعظم عظمة الكبرياء، الله. أشهد أن لا إله إلا الله، أشهد أن لا إله إلا الله، أشهد أن محمد رسول الله، أشهد أن محمد رسول الله. لا حول ولا قوة إلا بالله، لا حول ولا قوة إلا بالله، لا حول ولا قوة إلا بالله. الله أكبر، الله أكبر، لا إله إلا الله. What is Ibrahim? Ibrahim?
Yes.
Are you here now or not?
Yes, I am here.
Okay,
Yes.
but you sent me a message that I removed you from our session.
لا حضرتني أنت.
Okay, thanks.
توقع ما أدري.
Okay, Brian. Some reaction produce more water molecules. No evidence of a chemical reaction is observed. No evidence of a chemical reaction is observable, as HBr, its aqueous solution, plus NaOH, also aqueous solution, to produce NaBr plus H2O. So, some reaction produce more water molecules as this, and no evidence of chemical reaction is observable. Without spectator ions, H aqueous or OH aqueous produce H2O. Okay, so it's called spectator ions. Okay, spectator ions that not usually written as H plus OH, because H positive plus OH negative, this produce H2O water. Okay, listen please.
Types of reactions in aqueous solutions. Ions that do not participate in a reaction are called spectator ions and are not usually written in ionic equations. Formulas that include only the particles that participate in reactions are called net ionic equations. 2OAC plus CO2 plus AC, CO2s. Some reactions produce more water molecules. No evidence of a chemical reaction is observable. HBrAc plus NaOAc H2OL plus NaBrAc. Without spectator ions, H plus AC plus OAc, H2OL.
Okay, after that, the problem. Write the chemical, complete ionic and net ionic equation for the reaction between aqueous solution of barium nitrate and sodium carbonate that forms the precipitate of barium carbonate. So you must know these symbols. You must know these symbols, okay? So you are given the word equation for the reaction. What is the word equation of this? Write the correct chemical formula and physical states for all substances involved in the reaction as barium nitrate. It's simple will be BaNO3 by 2. It's okay? So it's what is this? Plus Na2CO3 plus Na2CO3, and also its aqueous solution to produce BaCO3 as solid barium carbonate plus NaNO3 aqueous solution sodium nitrate. Okay? Okay, so after that, balance the skeleton equation. You must balance it as we said before. Okay? Yes, Abdullah. What do you need, Abdullah? What do you need, Abdullah? Abdullah, what do you need? Okay. BaNO3 by 2 plus Na2CO3 aqueous to produce BaCO3 plus 2NaNO3. Okay, we balanced this sodium nitrate and we put 2. Why? Because in the reactants there are 2 sodium atoms that join our chemical reaction. So must produce 2 sodium ions, so 2 sodium atoms. So we add 2. Okay, so 2 sodium atoms enter the reaction, and also 2 sodium atoms produced from this chemical reaction. So it's the balance of this equation. Okay, so we must first balance skeleton equation as BaNO3 by 2 plus Na2CO3 aqueous solution. It's barium nitrate, and this is sodium carbonate to produce BaCO3 solid as barium carbonate plus 2NaNO3 aqueous, which is called sodium nitrate. After that, show the ions of the reactants and the product, ions only. BaNO3 by 2 can be separated into Ba positive 2 ion, barium ion, plus 2 NO3 negative, it's nitrate group, plus 2Na, it's a sodium ion, plus CO3, it's a carbonate group, to produce BaCO3. Okay, who can answer me why we didn't separate BaCO3 and put it as here? BaCO3. Okay, also we separated 2Na NO3 into 2Na ions and 2NO3 method group. Why we didn't separate BaCO3? Who can answer me? Can raise his hand. Think for a while why we didn't separate BaCO3. Who can answer me? Faisal, can you answer me, please? Faisal,
Yes, mister.
can you answer me, please? Why we didn't separate BaCO3?
ما ادري
Why? Faisal, why?
لاني ما دخلت معاك الحصه الاخيره.
Faisal, in the beginning, this equation I explained it. Yeah, this time, not in the previous session. At this time. Okay, Faisal. Okay. Mahmoud, can you answer me?
Yes. What is the
Why
question?
this equation? Why we didn't separate BaCO3? Why we didn't separate it? Also, we separated BaNO3 into Ba only and 2NO3, and separated Na2CO3 into 2Na only plus CO3. But why we didn't separate BaCO3?
I don't know.
Okay, who can answer me, guys? Who can answer me? Mazen? Can you answer me, Mazen?
I didn't know the answer correctly, but I will guess because it's a spectator ion, maybe.
No.
Hmm?
Thanks, Mazen. Ibrahim, can you answer me?
Yes, mister.
Can you answer me why we didn't separate BaCO3?
I didn't know.
Okay, listen. Muhammad Rafa,
Yes, Mr.
can you answer me?
Yes, one second.
Okay, why we didn't separate BaCO3?
But it's lagging. I can't. Okay. Why we didn't separate what BO3?
BaCO3, yes.
Yes, because of the element balance, equational balance.
No.
No.
No, it's okay. Can you listen to me? Guys, we didn't separate BaCO3 because it's a precipitate. And we said in the previous slide that we can't separate precipitate. Because BaCO3 is a compound which is produced as a precipitate in the bottom. So we can't separate it. Plus 2Na ions plus NO3 after that. Ba, we must make simplify to the similar ions in the two sides of reactants and product. So 2NO3 with 2NO3. 2Na with 2Na. Okay. So finally, the rest of ions will be Ba positive 2 plus CO3 negative 2 to produce BaCO3. It's the equation. It's called the net ionic equation. Finally, net ionic equation after making simplify to the similar ions as the both of two sides of the equation. Okay, So the net ionic equation includes fewer substance than the other equation because it shows only the reacting particles, the particles composing the solid precipitate that is the result of the reaction are no longer ions. Okay, I think that all students understood. Types of reaction in aqueous solution. To complete, listen please.
Types of reactions in aqueous solutions. Gases that are commonly produced are carbon dioxide, hydrogen cyanide, and hydrogen sulfide. 2-HIAC plus Li2SAC H2SG plus 2-LEC. Another example is mixing vinegar and baking soda, which produces carbon dioxide gas. HCl plus NaCO3AC H2CO3AC plus NaCl, AC. H2CO3AC decomposes immediately. H2CO3AC H2OL plus CO2G.
So these are examples. Gases that are commonly produced are carbon dioxide, hydrogen cyanide, and hydrogen sulfide. As this 2HI, it's aqueous solution, plus Li2S, okay, to produce H2S, which is called hydrogen sulfide, plus 2Li, okay, 2Li I as its aqueous solution. It's called lithium iodide. Another example is mixing vinegar and baking soda, vinegar and baking soda to produce carbon dioxide gas. Okay, vinegar and baking soda. H2CO3 aqueous decomposes immediately. H2CO3 it's aqueous because it's ions, so it will be decomposed into H2O liquid plus CO2 gas. Okay, this is the equation that change it into ions. Okay, of this. Another problem. HCl aqueous plus LiOH to produce H2O liquid plus LiCl. LiCl as you make exchange for radicals. That's called double replacement reaction. This reaction is a type of double replacement reaction. Okay, double replacement reaction. So HCl aqueous plus LiOH produce H2O plus LiCl. To change it into ion, H positive ion, Cl negative ion, Li positive ion, OH negative ion. H2O can't be ionized, so we must write it as it, H2O. Can't be separated because it can't be ionized. So H2O must be written as the same simple, H2O. Li positive, Cl negative. After that, make simplify for the similar ions at the both sides of the equation, this. Finally, we are get this equation H positive plus OH negative to produce H2O. This net ionic equation. Net ionic equation. Okay. After that, I think that we are going to finish and stop at this slide. Okay. Thanks, guys, for your participation. But please don't forget that we have small quiz and next Thursday, inshallah, and I will send, okay, the PDF to our WhatsApp group, and in electronic library. Okay, the quiz will begin in next Thursday, inshallah, at 8 o'clock p.m. and ends at 9. Okay, and ends at 9. Okay, this is I think that our quiz will be at first 1, 2, 3. First 3 lessons. Okay, 3 lessons. Reaction and equation, classifying chemical reaction in aqueous solution. Okay, reaction in aqueous solution. This is 3, and I will send it to our WhatsApp group. It's okay, guys. It's okay. Thanks for your participation. Enjoy your time. Okay, and goodbye. Goodbye, Gritten.